Hi, here we are again. Right now, I'm gonna do another example of algorithm tracing, like the one I did before. So in this case, we are gonna trace this algorithm that says loop count from 0 to a dot length. This is the length of the array, not defined yet. And the condition, if key equals array count, declared here, then found will be 1, else found will be 0, and end of the loop. We have this array established, and it has, in this case, we are gonna set that the length is gonna be n equals 6, so the final array will be n minus 1, so 5. But exactly the array does not define a length. But we're gonna use this in order to see whether the algorithm is right or is wrong. So let's start. We see that here we have a variable called key. So we are gonna have key. And key has to have established variable, because if it doesn't have an established variable, then the condition won't be met. What I mean is that key, in order to be compared to something, key has to have a value. And because our array is in numbers, then the value of the key will be in numbers. So let's just give key a number. So key will be equal to 8. Okay, so what the array means is that when key, in this case 8, finds the position that it has in the array, in a count array, then it will say 1. But if it doesn't find it, it will say 0. So that's why I declare here a found place, and the 6 spaces it has because of the array declared here. Okay, so let's start analyzing the array. So we have that key equals 8. So if 8 equals a, and because count starts from 0, it will compare 0, the first space in the array. So we have if 8 equals a0, then found 1 or found 0. So does 8 equals 3? I'm gonna copy these so that the analyze will be will be easier. So if key, that in this case is 8, equals a0, then found 1. But are they the same? No, because here we have a 3, because the position a0 has a value of 3. So no, they are not the same. Therefore, found will be 0. Perfect. Then, if key, that's still being 8, equals a1 because the count is going 1, it's adding 1 every time the loop executes. So we are analyzing a1 or c1, that's count, and it's 5. So 8 equals 5? No. So key does not equals a1. Therefore, we have a 0. Perfect. Let's continue. Loop count from 0 to a dot length. If 8 equals a2, because now we have array number 2, then found 1. But we see that the value in position 2 is not equal to 8. Therefore, we have 0 here. Perfect. We're now in space 3. So if key 8 equals position 3 in the array, then it goes found 1. And actually it does, because 8 is in position 3. So found 1. So here we write found 1. But the array does not end here. So we're gonna continue executing it till it's done. So we are in position 4. If 8 equals value in position 4, in this case 9, it will be found 1. But they are not the same, therefore we have a 0 here. Perfect. Last but not least, in our example, if 8, that's key, equals value in position 5, will be 1, but it does not. They are not the same, therefore we have a 0. Okay, this is going to be the end of our execution. But let's analyze our result. So as you see, 8 is only the same as the position in the array when it's 3. The other ones, they're 0, therefore we have 5 zeros and 1 1. But the thing we wanted to do is that whenever the key matches the position, it will stay 1. If it does not matches, it will be 0. But as here, I'm gonna highlight it. As in position 3, it was 8. It's supposed that all the numbers that continue needed to change. What does that mean? That these two positions needed to be 1. Why? Because we already found the key here. So if they go 0 again, then we won't ever have found 1 because they will always change. So the thing we can do in order to see, so when we analyze this, we see that the algorithm is wrong. So the solution will be that instead of writing the else size, we should have declared that found was 0. So that every time it executes, it says that found is 0. But whenever we found the key, then it will be that found turns into 1. So yeah, my solution is that found should be declared outside, so therefore our f1 will always change, and this won't happen, and it will maintain the 1 instead of changing to 0 because we already found our 1 variable. So yeah, that's one of the solutions that I think right now. That's why our algorithm is wrong. But there are plenty of more solutions that we could use to solve this array. But yeah, the point of this algorithm tracing is to know that the algorithm goes wrong, not the solutions we give to it. But yeah, obviously if it goes wrong, it won't run whenever you code it. So if you do not do this step by step, you won't realize that the result is wrong. That's why the algorithm tracing, it's important to know how to change something that won't run if you do it in a program. So yeah, that's it for algorithm tracing, and thank you so much.